if I need it.
Yeah, you will need it.
Yeah, okay. Oh, okay. All right. That's one way. All right. We're good?
Yeah.
All right. Hi, guys. Welcome. My name is Nathan Monnier. I'm going to be doing a talk on utilizing DNS logs to identify malware inside of your network. So, again, the name of the talk is another log to analyze because it's just that. Something else to go ahead and look at inside of your environment. So a little bit about myself. My name is Nathan Monnier, like I said. I work for Art of Exploitation. They're the ones paying for me to come out here right now. So a little bit of gratitude is necessary. I also work with Hackers for Charity. I do the Food for Work program. I started the Hack Hunger thing. I don't know if you've seen the T-shirts, the one I'm wearing, or the new one that was at DerbyCon, the Hack Hunger. Hunger is no game. Hunger Games inspired T-shirt. But give them a little bit of support. Go buy some T-shirts if you can. So on a general, like high-level overview of what malware is that it's constantly evolving. We all know this. It's very generic. They want to remain evasive to detection techniques such as antivirus or malware, any sort of advanced threat protection type of device a vendor will try to sell you. So it's constantly evolving. Their modes of communicating also are evolving as well. A lot of products out there will try and go ahead and stop them. I try to identify the malware so it makes your life a little bit easier. However, the signature-based detection, such as like antivirus, is only catching about 3% of the stuff that's out there. So it's only catching the known bad, right? So what we're going to talk about here is what we can do on our side from an analysis perspective on how to identify stuff those expensive things are failing you on. So we're going to look at those logs and try to go ahead and detect what those expensive tools are failing you with. All right, so it's not advancing. All right, so generally speaking, very generic description of malware. A user clicks something, right? A user, not a security person like us, because we never do something stupid like that. Clicks something, it downloads something they shouldn't have. They open an email, and they get infected. They become, let's say, a bot inside of their botnet, and it needs to communicate to their C2 server, their command and control server. So it needs to communicate somehow. There's some specific ways that malware typically connects: IRC channels, P2P, social networking, going out to a website, grabbing an HTML file, and then inside that HTML file actually has the command line interaction that it needs to do for that backdoor on that box. So there's a few different ways it can connect out to its bot herder. If it's using DNS as opposed to IP addresses, DNS has to be used to resolve that fully qualified domain name, or FQDN for short, to resolve the C2, the command, the bot herder, his IP address to a host name. So it needs DNS to actually go out and connect to that, whoever's controlling that botnet. So just a very generic example, kind of modified this from Mandiant's APT1 report a little bit. So we have an infected user. He needs to go out and connect to a C2 server. He has to resolve whoever the host name is for the C2 at that current moment in time, does the DNS request, gets the IP address so he can then go out of his network and connect to the bot herder or the C2 server to get instructions on what to do, whether it's a interaction with the backdoor that's installed or just doing a directory listing of things that have changed since the last time the person has interacted on that, the bad guy has interacted on that infected user system. So it needs a way to go out there and communicate. So I'm assuming everyone is pretty familiar with how DNS works, right? All right, so let's go ahead. So DNS logs, the purpose of this talk, are commonly overlooked as a security asset for analysts defending their network, mainly because it's not really implied that it is a security feature, right? It's just DNS. That's it, all its job is to resolve host names to IP addresses and go out there. So we're going to go talk about how to use those logs, or more effectively, I guess, packet captures too, to go ahead and try to identify potentially infected machines on our network. So we're going to do this through establishing DNS query baselines, query and response baselines. We need to know what's normal. I'm going to emphasize that a lot, baselining your network. It's one key thing that you have to do. Also, from those queries and responses that you get back, you're going to have what's called an NX domain response on some of them, and we'll talk about more of what that actually means and why it's important in this aspect. Also, analysis of successfully resolved DNS responses. We're going to talk about DGA in a little bit and querying out and getting some NX domain responses. Sometimes the infected machine is going to be successful in querying out to a C2 server. So we need to look through what's also successful as well to identify what is anomalous in that in those successfully resolved queries. And then we're going to talk about how to identify what is anomalous in those domain names. All right, so we're going to talk about what's the basic stuff that we need to look for to help defenders defend their network. All right, so we've already kind of covered this. DNS interprets IP addresses to host names, or host names to IP addresses, as you will. It's extremely helpful for your grandma, right? It's much easier for her to remember Facebook.com as opposed to 74.79. whatever. Extremely helpful for users. It's much easier to, for us to remember something.com. It's also extremely helpful for attackers, mainly because if they're using a basic set of malware where it just has a hard-coded IP address, well, if you figure out what IP address they're connecting to, right, what are you going to do to that IP address? Block it, right? And then they're screwed. Well, that's the kind of thing, right? It's been evolving. They don't just do that anymore. So they're going to use fully qualified domain names to resolve to IP addresses or their attack infrastructure, because then they can utilize DNS to start rotating through different servers on different sides of the world. So it's going to make a job of a defender much harder. Oops. We'll go back. All right, so yeah, some of the things that attackers can utilize are these different types of DNS, fast flux, round robin, dynamic, to make it a little bit harder for you as a defender to identify where to start blocking. All right, so malware and DNS, looking at the IDS packet captures is going to give us our IP addresses to go ahead and start to identify as malicious or potentially anomalous. Most DNS servers on their own, they do have some logging capabilities. However, it's not generally recommended to go ahead and utilize those because it could, severely impact the DNS server, but even if it's just a little bit of impact to the DNS server, you don't really want that because its job is to resolve those host names. So realistically, in my opinion, you're going to want to go ahead and utilize a packet capture to capture these packets so you're not impacting the DNS server at all. So if you want, you can go ahead and start to utilize some of the logging capabilities with the DNS server. Here we have a sample output from bind DNS. The top one up there is just a very basic from varlog syslog. And what we're seeing here is the queries out of our network to wherever.com. In this case, we have example.com, Facebook, and Skype. We see the queries, but we don't see the responses. So we have some good stuff to go off of with that specific log. However, we don't have everything we need in this, well, specifically for what I'm talking about right here. So we only have half of the conversation, technically, and that's never really good, especially if you're starting to do analysis and trying to identify exactly what's going on and what happened on your network. You want to have the full, all the pieces of the puzzle to put it together. At the bottom here, this example is just a modified bind configuration to output debugging. And still, again, like I said earlier, realistically, you want to use a packet capture to do this because you don't want to modify, you don't want to impact that DNS server at all because it's keeping the services alive on your network, right? So it's keeping everything you need going based on host names. All right, so speaking of packet captures, some general recommendations. Grab all the packets, or capture all the packets. The meme. I was going to put that in there. I didn't have time, but so grab everything. But that's going to have some impact, right? If we're grabbing all the packets, we're going to need a place to store them. And specifically, depending on how long you're storing them for, you might need a lot of storage. Are you just doing it for a week, a month, a year? That would be a lot of packets going through your network, depending on the size of your environment. So some general recommendations is to capture everything. That way, when you're analyzing those packets, you have everything that you need. Unless you specifically know you're setting up just this packet capture for DNS queries, you don't want any SMB because the Windows machines are too talkative. You can go ahead and start setting those, but I'd recommend if you have the storage capability, go ahead and set it to capture everything. And then when you open up in Wireshark, go ahead and use a view filter to start to delineate what you're actually looking for. As a side note, on just doing, having done incident response before, it's always frustrating when you see an alert from the IDS system. You see that it flagged an attack to a machine, but then you don't have the packets of what actually was the payload. Or logging turned on at all, right? So you don't have any. I see something happen. I don't know what it was. Okay, was it a false positive? Was it not? If you're starting to eliminate certain things, like was it a Windows attack aimed at a Solaris box? Well, okay, that probably didn't work. But if it looked like everything lined up perfectly, and you don't have those packets, it's kind of frustrating, and it's a lesson learned type of situation. So, generally speaking, I'd recommend if you have the capability in the storage, go ahead and fire up the machine and start logging. That being said, place those sensors appropriately. I already mentioned not using capture filters as opposed to view filters. And I have that kind of bolded, baseline the network. You need to know as a defender what's normal on your network. What type of traffic are you seeing? What time of day? Where it's going? And who it's coming from? And we'll go into more of that in a little bit as well for different departments of your organization. And then also, as a side note, I'm not a lawyer, so stay on the correct side of the law. I did not go to law school, but I did stay at a Holiday Inn Express last night. So, actually, I stayed at the Marriott, so I just paid more, I guess. Consult your legal team. I'm sure you have one if you work in an organization. If you work for the government, you probably don't have to worry about being on legalities, but as we already learned, all that stuff's legal anyways yesterday. So, yeah, exactly, yeah. Consent to monitoring. What's that? Nice. Consult your Facebook profile. All right, so that being said, take whatever I say as a grain of salt. I'm not specifically giving you legal advice here. And advance. Enhance. All right, so going back to DNS, what we're looking for here, we know that the malware uses specifically FQDNs to go ahead and communicate to their command and control servers. What can we do about that now? So we're going to talk a little bit about some different defensive techniques that we can utilize. So the first one I have is called Kill It With Fire. And if it would advance. We have Stoner Stanley here, and he's recommending basically to just kill all HTTP requests out to the internet from the user set, right? So while that may work, you're going to start a riot probably with your user set if they can't get to Facebook or look at cat pictures on the internet, right? So yeah, they're not. Your workers are not working anyway, so just kill all their access. So. But yeah, I love this picture of the grumpy cat. It cracks me up. Cat pictures. That's pretty much what the internet was invented for, right? HTTP. Responsible for 99% of all traffic is cat pictures. And yeah, and I don't know what's porn? I'm sorry. Yeah, I've never heard of that. Hey. What's that? Nice, yeah. So we have the kill it with fire method. It will solve your problems, I guess, in this situation, but it's not generally recommended. Like I said, it's going to start a riot with your users. They're going to show up at your door with pitchforks and try to kill you. All right, so another thing is, why don't we just blacklist the malicious FQDNs, right? So Stoner Stanley kind of has a point here. We could do that, but that's only the known bad, right? So we know what's bad, but we don't know, to quote Donald Rumsfeld, there's unknown unknowns, right? So we're trying to look to identify that specific thing. So we know the known bads, and we can do that, and that's part of our defensive techniques here. But it's not the the end-all be-all, mainly because of what's known as DGA. Has anyone heard of DGA before? Malware DGA? So what DGA is a domain generation algorithm, and it's just that. It's an algorithm that's going to be within the malware, and it's going to go ahead and make a list of potential domain name candidates that infected machine is going to go ahead and query out to try to contact his C2 server. So let's say, for the sake of ease of use, or we're going to say it's going to generate 10 specific domain name candidate choices, right? So something weird, whatever .com, whatever 2.com, whatever 3.com. It's going to go out and try to query the DNS server, and one of those 10 whatever .coms are going to come back. One of them is going to be successful, most likely, because it needs to contact its C2 server, but 9 out of the 10 are going to fail because it's not utilizing that fully qualified domain name at that particular moment. So that's going to generate something that's important to us later on, known as the NX domain response. And we'll talk about that in a little bit. Like I said, the malware is going to attempt to connect out. The malware-infected machine knows the DGA, and so does the C2 server, so they're both on the same page, and they both know what a potential candidate is. Conficker was actually one of the first sets of malware to use this, and also has been noted through various research that other malware has been evolving to support this as well. So it's becoming something that's been being supported to enhance invasion techniques for older sets of malware or crimeware. Could be used as a backup strategy as well in case you get blacklisted. Advance. All right. So malware and DGA, the top malware as of about 2 months ago, when I put these together, utilizing DGA includes the following. Also this quote from Gunter Ullman from, I believe he was at Damballa at the time, I don't think he's there anymore, Damballa Labs. He said, while DGAs are not new, the rate at which they are being adopted and their ability to elude the scrutiny of some of the most advanced malware analysis professionals should be a great concern to incident response professionals. So it is, a lot of these sets are evolving. They're trying to utilize this because it's harder to track down. It's not as easy as identifying the known bads. Pushdo, which was one of the oldest botnets, has recently evolved to support this as well. So it is being seen that it is being evolved out there. So let's keep going. Not now, Stoner Stanley. Jesus. All right. Go back to being high, Stoner Stanley. All right. I love that meme. All right. I saw that on 4chan this morning, so I added that in. All right, so let's take a look at a real-life case study of where analyzing DNS logs have actually been successful. The most popular one I can think of is the second most popular website on the internet, known as Facebook. Come on, advance. So protecting people on Facebook, the security team on Facebook, they have a Facebook page I'd recommend. They don't do a lot of posts, but they have some good ones. This one was one that was particularly interesting to my talk. It was protecting people on Facebook. They identified, their security team, a suspicious domain name in their DNS logs. We'll talk about how to identify what is suspicious or malicious out there, or anomalous for your environment. So they identified something on their corporate network. Now it wasn't affecting their end users, so they said. They tracked it down to a laptop employee and then proceeded to tar and feather him repeatedly. I don't know. I don't know what actually they did to him, but they tracked it down to the employee, so the note said. And then they identified it as a Java 0-day. Well, of course it was Java, right? Has anyone ever worked in incident response before? The general recommendation is always start with Java if you get infected somewhere, so always look for the Java exploit. What's that? Nice. An announcement? Nice. I'm sure, I guess I'm not getting any love from them anytime soon. So, so they identified it to a Java 0-day. From there, they went ahead and, once you identify that you've been hacked, what do you do for your network? You go out and look for that file, right? Or that specific exploit or other hosts that are also infected. So they searched for that malicious file throughout their entire organization. in their note, they specifically said it did not affect their end user sets. So they said it was on the corporate side, which bravo for actually disclosing this information too, because that's also beneficial to the whole community, is talking about this stuff and not keeping it secret just to save face or to keep the bottom line promoting. So bravo for that. They identified it, searched for it. They notified Oracle. Oracle said it was a bona fide 0-day, and then released another patch to their awesome application. So what's the lesson learned from this? So specifically that you can identify malware in your network through looking through certain things like DNS logs that, it's not, like I said, notionally a security asset, right? It's not a tool or something specifically that was built for identifying or protecting your network. It was built for resolving those host names. So we can take away that there are other things that are at our disposal sitting right here on our laptops, logs that we can go ahead and start to search through that we can utilize to help protect ourselves. So the lesson of the story is that, and then also as Dave Kennedy on the Katie Couric show just recently said, number one of the top 3 things to protect yourself on the internet is to avoid Java completely. So now I'm not getting any love from them either. So, but yeah, bravo for Dave for actually going on national TV and saying that, not just for the HackerCon community. And let's go ahead and pick on Java one more time. So, so removing all of your protection and redirecting to malicious website. 3 billion devices run Java, and all but one, the guy who developed Java. Ruined by Java? Okay. All right. So, got some chuckles in. I'm going to get sued. All right. Nobody watches this. All right. Identifying malicious traffic objectives. So some of the things we're going to start to talk about now is, okay, so we know what we can utilize DNS for. Now we're going to talk about specifically how to do it. So we're going to need to do some baselining. Like I said before, baselining, know what's normal on your network. So DNS traffic baselines, where your user's going out to, querying for malicious domain names, analysis of the DNS traffic, so the NX domain responses that we talked about before, and then specifically anything that's successfully resolved as well. We need to see, because like I said, one out of those 10 that fail is actually going to be successful. So we need to identify what is anomalous and what's normal. If we identify a host, we need to go ahead and analyze additional traffic from that suspect host and try to see what else it's doing, and try to start to see pattern analysis on that. And then specifically, we'll talk about how to identify what is anomalous for a domain name. All right, so we need to know what's normal, like I said. Sorry, this is not advancing with the slide deck. 1 second. All right, so what's normal for your baseline? So we need to know what our top level domains are. So the .com, the .govs, the .mils, where our user set going to. Most likely it's going to be .com, right? Unless you live in Europe or something like that. But most likely you're probably going to see a lot of traffic going to .com, .org, stuff like that. So we also want to know specifically of our users where their second level domains are going to. So Facebook.com is probably on top on the list. Google is up there, most likely. If your grandma's using it, maybe Bing.com or something like that. Yahoo.com, I think they're still open, right? So, top host performing the lookups. So who in our user environment is going out to the internet? Well, everyone, probably, right? The Yahoo toolbar, yeah. Yeah. Hell yeah, I want that. Double click. Clicking stuff is fun on the internet, right? Shout out to Jaded Security, right? Don't click shit. Top hosts that are performing the lookup. So who is your most proficient internet surfer out there? So who are the people that are surfing the internet the most? What machines are going out there? Are my servers going out to the internet? Is my domain controller going out to the internet? That's freaking weird, right? So I need to identify those things because those are all things that should not be happening, right? So we need to have a baseline of normal activity. DNS queries, if you can, per host, network, domain, and if you're a mega company, per site, if you have a lot of locations. So what is also normal for your different departments in your organization? Now, this is going to be kind of hard because there's a lot of different departments. Where is HR going to on a daily basis? You know, the recruiting people, they're probably going to dice.com, monster.com, security job, or clearance jobs, whatever.gov. So that's normal for them. Maybe if you start seeing your IT people go in there, you might want to get, you know, hey, you need a promotion, or how you feeling today? But we need to go ahead and see what's normal for our user set, so we can establish a baseline there as well. So we start seeing that the HR people are starting to go to security sites. So what are they doing? Are they doing research or this and that? So having a normal C or baseline for them as well is also an important tool for you too. And then also averages of queries for the time of day. So the peak usage time, probably right after lunch, right when they get to work, people are checking their email, clicking stuff, logging into Facebook, saying, hey, I hate Monday, it really sucks, you know, I don't want to be here today, this and that. So establishing a peak baseline for the times of day as well. So if you start seeing a lot of bandwidth at 2 in the morning, I mean, that should just set off a red flag for you as well too, right? All right, so we need to have what's normal. All right, so also with those NX domain responses, everyone remember what I was talking about with the NX domain response? They're usually a result of like a fat finger. So if I type in google.com, but I type in 3 O's instead of 2 O's, it's going to give me a, you know, server not found, or maybe Google actually has that name, so that doesn't happen to people. But in this case, let's say I type in google.com with 3 O's, and it says, you know, page not found. But on the other side of the equation, from the web interface, I can see that, you know, the page was not found. But what actually is happening is the DNS server is saying, I'm sorry, I can't resolve that host name. There's no IP address to go ahead and connect your session for. So that's what's known as an NX domain response. It's basically I'm sorry, you failed response. You try again. So it's a fail response, saying that I cannot go ahead and translate that for you. Like I said, they commonly happen with fat finger errors. So baseline that too. Who has the chubbiest hands in your environment? You? All right. It also happens with that DGA that we mentioned. So DGA, it has an algorithm where it's going to go ahead and send out, let's say, 10 potential candidate FQDNs, or fully qualified domain names, and 9 out of the 10 are going to fail, and then one of them is actually the one that's hosting the C2 malicious server. So we're going to get some NX domain responses there, just as the nature of the game. So we need to know also with that what is normal for the hour, day, week, month. So we have these baselines to compare and contrast to when we're doing the analysis to identify if there's something messed up on our network. All right, so come on. All right, so a little quote up there from Damballa Labs, another shout out to them. They did a lot of when I was looking at this stuff, they had a lot of good information that I borrowed from them. But to quote them specifically, they said 90% of MERFET victims out there generate 10 NX domain responses per day, while 92% of all devices within the network that they notice create less than 10x domain responses per day. So right there is a pretty good indication of how we can use those NX domain responses to identify potentially infected victims, right? And we start seeing a spike in traffic. Either that guy's got really fat hands or something's going on in his system. So if your average NX domain response for your entire hour is 25 per hour, that's pretty high as compared to that quote. And then you start to see a spike of 50 from one specific domain, one specific host, then that machine is probably infected, right? Because the amount of NX domain responses on that machine is too damn high. So, sorry, I like to use a lot of memes on this one. So it's too damn high. There's too many NX domain responses coming from that potential machine. You need to start doing some more investigation at this point. Everyone with me so far? All right. All right, so some of the things we can do, query for malicious domains. There are certain things at our disposal, including specific websites that I have listed down at the bottom. Once we have some, we can go ahead and start to blacklist them, but again, that's the known bad again. We're trying to identify what's unknown. the unknown bad. But some other places to start if you want to start doing like a sinkhole. Malwaredomains.com, malwaredomainlist.com, malware patrol, Zeus tracker, those are all at your disposal and open to the community. So just some, it's really small on this presentation, isn't it? That's malwaredomains.com. They have some black hole files for you. If you want to go ahead and download those and create your own black hole. That's not really the purpose of this talk, but it's something at your disposal and it's open to the community. So it's updated, I think, on a weekly basis. I can't remember entirely how often it's updated. But it relies on people reporting these known bad. So if you identify something that was unknown previously, go ahead and do that interaction and report up to these places that are trying to help defenders, because defense is freaking hard, right? It's less sexy than offense, and it's not as fun. It's much more fun to cause the mayhem than it is to respond to the mayhem. I did IR work, and it's much better to be a red teamer. So help out the defenders as much as possible, if, unless you're a bad guy. Malware domain list as well. That's another good one. I know it's really hard to see, but it's listed here. It has IP address, the reverse lookup, the domain name as well. It also tells you a little bit about the country code it's originating from. And then also what's kind of cool too is that if you see this traffic and you identify the IP address, it also says what known exploit it's been associated with. So that also gives you, if you find a known bad, a starting point. Okay, why is this machine connecting out to this IP address? It's associated with this specific exploit. I need to look for that, maybe do some more research. What is it that that exploit does? And then I can go ahead and hone in on that specific machine and try to clear it out and then find it on the rest of my network. So that's another useful thing there as well. You can also do a domain name search at the top. I know it's kind of hard to see, but there is a search functionality right up there. So if you see something in your DNS logs, you can go ahead and jump on one of these sites and see if it's a known bad at this point. And there's also malware patrol. So that's another thing that's at your disposal. All right, so we know that we need to look for the NX domain responses, right? Focus on those. That will give you a good indication of a machine being infected. It's going to reduce the amount of data to actually sort through, because we were talking about earlier was creating a huge packet capture file, right? So it's going to reduce the amount of packets to actually start to sort through. Are those NX domain responses that you're seeing in your packet captures, are they within your normal baseline? This is where the baseline comes into effect again. Is it normal? Okay, it looks like, oh, there was 11 today. It's usually around 10. Okay, well, let's look at that. Let's look at those 11. Is it within my threshold of suspicious activity? Was it, of those NX domain responses, does it look like it was a fat finger? So was it Google with 3 O's instead of 2? Or is it something kind of funky looking, like a whole bunch of consonants and numbers? .ru. What was that? Was that? Oh yeah, funny code, right? Yeah. I was actually thinking about that when you were talking about that the other day. So just didn't have enough time to actually start to look to put this in there. Of those NX domain responses, do they include suspicious domain names? And how do you know what a suspicious domain name is? Well, you can probably start with some of the major players. If I see my company connecting out to .cn or .ru, I'm going to be a little bit. It's going to be immediate red flags for me, at least, unless you have specific business functionality in those countries. Of the successfully resolved domains, are there any known malicious ones? And we talked about how to identify those. The known bad. Any suspicious or anomalous names. And we'll talk about how to identify that too. All right, so identifying anomalous domain names. One of the key things for that is domain name length. In this case, who mentioned it yesterday that size does matter? Was it your talk? Yeah. All right. Size does matter in this case for domain name length. Why that is because typically the more popular a top-level domain gets, the less names there are to actually use for .com, right? Or .gov, or, well, can't really register .gov, .org or something like that, right? So with TLDs, the more popular it becomes, the less resource there is to actually get a google.com or something within, the 5 to 8 letter range. Typically, top-level domain, or excuse me, second-level domains for the top-level domains are 12 to 15 characters, or greater than that is going to fall outside of normal, because it's going to be just like google.com is easier to remember than an IP address. Something that's super long is not going to be a very convenient name for a user to remember, right? So if you have to remember I don't even know as an example right now, but if it's outside of google.com or something, if you think of all the major websites, they're typically about less than 12 characters. So average domain names, as it noted, is about 8. As a TLD becomes more popular, again, it's going to be harder to get those available in that specific range. It's going to be something that's memorable to an end user. So that's going to be something that's good for us, because we can start to establish baselines there too of what's normal. So like I said, TLD popularity is like Viagra for domain name links. It just keeps growing and growing until you have to get another top-level domain name. As a side note, a typical Zeus query was greater than or equal to 33 characters. I mean, so right there, that's just instantly out of our normal range right there. So we can start to flag that just on a cursory look through our domain logs too, right? I mean, if you see a query and it's this big as opposed to Facebook, Skype, it's just on a cursory look, that's going to fall out of your typical normal range. All right. So what else makes a domain name anomalous or suspicious to a defender? Specifically, character contents, and that's alphanumeric characters. Example being, 2kjpdsf45.com. Something that's just consonants and numbers strewn together, right? It's available because nobody wants it. It's not easy to remember, so it's not going to be a legitimate site, most likely. So that should also pique your interest too. So sometimes, as noted with the domain name link, these may not fall out of that scope. So don't just go off of one or the other. Combine these. Utilize what looks normal, how many characters are in there. Is it just a whole bunch of consonants, vowels, and numbers strewn together? And also we have what's known as doppelganger domains. So basically, everyone familiar with what the doppelganger is? Something that's trying to take on another identity. So doppelganger domains, missing the dot between a subdomain and a top level. That's also something that people have seen. Garrett Gee, he did some research. I used to work with him at the National Incident Response Team for the Federal Reserve. He did a talk about 2 years ago about doppelganger domains. Specifically, they set up some email servers trying to get people fat-fingering these things. So that was a little bit different topic, but it does happen where people accidentally do this, or they might not notice this as well, too, if they're connecting out to cn.yahoo.com. That's actually, if I remember correctly, yeah, these were actually, I took this out of Mandiant's APT1. This is stuff they actually seen that APT1 was doing. Normal users may not notice this. As an example, AOLonline.com, substituting that 1 for that L in that case. Taking out the dot in between the top-level domain and subdomain and top-level domain. Or then, just missing double vowels or consonants. In this case, facebook.com. Something that maybe as a security expert, you would identify or hover over that link and look at the bottom of the screen to make sure you're going to where you're about to click, but normal user sets typically don't do. I typically go with, would my wife or my grandma or my father, would they click this type of stuff? So if the answer is yes in that case, well, I need to teach them or explain to them a little more. But if the answer is yes, they might do this because it looks like it's coming from me, or I typically go with that. So I know sometimes us as security people, we think that everyone should know all these things that we know, but our user set, as proven time and time again, doesn't really know this information. So the low-hanging fruit is going to work on that subset of people. It may not work with us, and we may scoff our eyes or roll our eyes at it, but it's going to work because it does. It's proven time and time again. just look at all the user-driven attacks that have been sent out. All right. So some tools. We don't typically like to recommend specific vendor tools. We like to focus on methodology more, and then utilizing what's available to you at your disposal. So if you have the funds to, let's say in some of our courses, we don't recommend to show you how to use Metasploit, not that we don't recommend it, or show you how to use Core Impact. We show you the methodology behind those tool sets. And in this case, too, we're going to talk about some of those that are equally available to you as well, and we like to focus on the open source ones. So the ones we're going to focus on, we've already talked about utilizing packet captures, and that's not really what this talk is about, how to do packet captures or view them or sort through them. But at your disposal, TCP dump or Wireshark for GUI analysis. But specifically for this information for DNS, there's two specific tools that are pretty cool, DNS Top and Passive DNS. The first one is DNS Top. It's a libpcap application from TCP dump. Basically, it's going to display the various tables, like it says, of DNS traffic on your specific network. And some of the things that we're concerned about here for DNS Top is that it has the ability to display the source IP address and response codes, which is important because we didn't see that before in the logs from the DNS, which we also didn't recommend doing because it might impact the DNS server. So we're going to get those response codes that we're looking for or particularly interested in this particular analysis. And then also the top level domains that's connecting out to. And also it does second level domains, and it has this, this awesome little, it sorts it out for you. It's pretty cool. I know this is a little bit small to see for you guys back there, but it can read packets on the fly, or it can read in a packet capture. So we can see some different metrics here. We can see the query sources, where it's coming from. The first level query name, so who's my top connection out for top level domain. So .com, it looks like I have a count of 247 at 56%, then .org, .net, and so on down the line. Then specifically those second level domains. So what's my most popular website for my users in my environment? Where are they connecting out to? Also query source and second level domains as well, so we can start to correlate who's doing what and who's at the top of the list for that and where they're connecting out to. And then also those query types too, but that's more of what's going on for mail exchanges, zone transfers, stuff like that. But still useful for you. It's open. It's on dns.measurement.factory.com and at your disposal. There's also a tool called Passive DNS. It basically works similar to DNS Stop. It's just a little bit different. As the name implied for DNS Top, it's a top type of monitoring solution. This one's a little bit differently. It's going to be also used to collect DNS information. Also, it can sniff from an interface or read in, just like we talked about with DNS Top. Let me get back on. Yeah, sorry. It also can duplicate the DNS answers in the memory, limiting the amount of data with the log file without losing the DNS answer. So it has a little bit more functionality than what we saw with DNS Top. But they can be used together to provide you a better picture. So with logging with the NX domains, you can add that in for passive DNS. It's great, like I have noted there, for quick analysis of, like I said, I know I only have 10 NX domain responses per day. What's it look like right now? Okay, I'm good. I'll move on. I got other fires to put out at this moment, right? Because there's not always just one fire to put out. There's multiple ones. They usually happen on Friday afternoon around 4:30, right? So, it also can support DNS over TCP as well, and IPv6. DNS Stop only does UDP currently. That may not be important to you, but if you're interested in like your zone transfer information, that all occurs over like TCP. So that logging is important too for seeing who's messing with your DNS servers. Okay, so back on topic. Logging to standard out NX domains and other DNS records. It can do all that as well, so it's pretty good. And there's also a cool web interface, right? Because sometimes we get tired of looking at that frickin' command line environment. If we're doing defense, we might as well utilize all the pretty stuff, right? So it has a web interface. We don't have to live in a command line environment as if we're on a red team. So it has a what's called funneled and PDNS.UI web interfaces that you can actively utilize this and start to identify what's going on in your system. So it can do different things. So here we have, I have the example demo site up here for funneled or passive DNS. You can search for by different type of record types, A records, B, CNAME, on down the line, MX requests, stuff like that. You can also do special reports, and this is where we're looking at what we're talking about specifically with the NX domain responses. So NX domains, where are they, and where's it going out to? So show me everything that's NX domain in my environment, and I'll show you all the hosts that it's logged or it's collecting packets on. You can also do an advanced search as well. So if you have a known bad and you want to see if it's in your environment, like let's say you read an article or you saw something that's recently come out and it's going to here, and you want to see if your users are going there, you can go ahead and plug that in as well. You can plug it in to go ahead and show you another, also do an AND for the specific response and see if it was successful, if it was unsuccessful, are there machines out there trying to get out there, and what they're doing. So it may be useful from another perspective too, for seeing where your user is going that you specifically told them not to go, and they're still trying to get out there. So in this case, it's also at your disposal. So I have a query type of evilmalware-site.com, and then the answer of NX domain. So are users trying to get out there, and did it fail, or was it successful? When this was occurring, so if you have a time frame of an incident, you can narrow that down as well. Does that make sense? All right. All right. So as I mentioned before, if we've identified a suspected host, what can we do at that point? Having the baselines are key here. What connections are they making, and what was normal for them a month ago, a week ago, that we can compare this information to? What were they typically doing? Established and past connections. So that's very important here. The C2 server, is it rotating through a hosting infrastructure? So we see him connecting out to Kirplakistan, and then we see him connecting out to Kirplakistani somewhere else on the internet, right? It keeps rotating through. What's that? Kirplakistan, you can't trust that place. Known terrorist. So where are they going through? Are they rotating through their infrastructure? I keep seeing that they are making these connections to Russia, then it's China, then it's somewhere else on the internet. Why are they keep changing? Why are they going to those places? The IP addresses, are they malicious? Again, we'll consult the known bad in this case. Is it known bad? Is it legitimate? Is it a real website? Can we block these IP addresses? We can't just go ahead and block an IP address willy-nilly, right? Because what if there's actually another web server hosted on that same site as well that's an actual legitimate business or client, right? We don't want to block their access into our environment if they're using like Amazon services, or they're using an IP address to host multiple websites. One just happens to be malicious, right? So those are some things we need to consider. Can we blacklist the IP address? Well, how will this affect other legitimate FQDNs in that case? Is there an actual business case to keep that connection there? Again, that's not really sometimes our concern, but if it affects the bottom dollar, it definitely affects our standpoint, right? Because if we start closing access off to customers, and it starts affecting the bottom line at our business, because security is not really the business in most places. Heads are going to roll. Someone's going to come down and say, hey, open up all those ports again, open up all those connections again. We need to keep this moneymaker going. So some of the things we need to keep in mind here. And advance. All right, so on a side note, I have this slide notifying the community. Like I mentioned before, defense is not as sexy as offense. It's kind of the redhead stepchild of the security world, unfortunately. Everyone wants to be an offensive guy, right? It's much more fun to cause the mayhem than it is to respond to the mayhem. But on that side note, doing instant response, it needs to be done, right? It's not easy, and make everyone's life easier that also shares that pain with you, right? If you're doing IR or network defense work, help other people. A lot of people have the tendency nobody wants to notify that, hey, we got hacked and this is how it was, unless it was publicly made available, right? But no one's going to volunteer the information that, hey, we really screwed up here, guys, and we got hacked, and this is how it happened, and this is how you can learn from it, because it's going to affect your reputation as a business, and if you're on the security team, it's going to affect your reputation because you didn't catch it. But it happens. So share the knowledge. If you have to do it anonymously, upload this information up to somewhere and say, hey, we're seeing this. Just notify the community and help out a little bit. So share that knowledge. What else was I going to say? So update that information back to the domain name blacklist. If it's just that, you can do it anonymously if you need be. And notify the domain registrar that something bad, they need to go ahead and kink that guy. Also, another fire to put out in this case may be attribution, which is a very hard game. Unless you have a significant amount of time and resources at your disposal, good luck, because anybody that's skilled is going to be able to hide their tracks pretty well. The most famous, obviously, attribution case would be the APT1 report from Mandiant recently. That took a lot of resources, a lot of time dedicated to specifically just doing that. And they also had some, assuming that they had some connections that made other things a little bit easier for them to get that information too. So some things to consider with attributing an attack is it important? Do I have 18 other fires in my network currently that I need to put out? And am I going to be able, if I even identify that who it was, can I prosecute beyond it, is this going to go to trial? It may be just another fire that you okay, I got attacked, move on. There's 18 other fires I need to put out. So some things that may hinder if you decide to do this, your attribution is dead-end investigations, as I mentioned before, not logging, not doing packet captures after you get an IDS alert, saying, hey, this attack went out, but you don't have any packets to see what it was. So it may be a false positive, it may be a real attack. Good luck. So those things are all lessons learned type of environment that you adapt and say, hey, we should have been doing this. Let's start doing this now from now on. This is now a part of our incident response capability. Attackers using multiple jump points. I have a talk on redirection. It's kind of one of my favorite topics. Basically, how to hide yourself anonymously on the internet utilizing multiple jump points. So if you got an attacker coming from, what it looks like, the attack is coming from China, right? But that's actually the last hop on his redirection chain, right? His jump point chain to get to you. So now I've attributed back to China. Okay, well now I gotta investigate, and then hopefully they have logs and they let me see those logs and they give them to me, and then I found out, hey, it actually was another guy, but he's coming from India. And now I gotta translate that back on. So if somebody's good enough, they're gonna stay anonymous out there on the internet. I know there's probably some, you can't really stay 100% anonymous. There's some OPSEC failures at some point in a lot of people's lives, as just happened with Silk Road, right? Back a little bit of OPSEC failures, but it's a lesson learned type of deal for everything. With jump points, if I wanted to be really malicious, I would use countries that don't get along well together. Exactly, I was about to say that. India and Pakistan, Israel and everywhere surrounding it, Iran and somewhere else, hell, that might start World War III, but, at least you're not going to get caught, right? So hopefully you got a fallout bunker. So, attackers using good tradecraft, again, like good OPSEC, making sure they're using multiple jump points from destination, from their attack target systems to their in-target boxes. All that to say, I'm going on a little diatribe here, the attribution is freaking hard, right? So it may not be of concern at that particular moment for your investigation. And then other good hackers are hard to pinpoint down. Nation-state sponsor groups, such as APT1, or government. I have to drink now. Cyber attack forces, right? All right. Oh, and that wraps up everything. Do I have any questions? Bueller? Mr. Bill Gardner. APT 1, right? Oh, yeah? I'll open that PDF right up. Uh-huh. My take on that particular report? On camera? Really? They do IR work, right? So they had access to customers that may have been attacked in that situation, right? So they may have actual physical control over those boxes, right? I'm not familiar with the video screenshot part. From what I saw, they had a lot of customer sets that were attacked, and they were able to correlate this information. But yeah, I wasn't aware of the video information. Yeah, because yep. Yeah, from the report, they didn't name specifically who, but I'm assuming that since they are mandated and they have a lot of access, they are incident response people, right? That's one of their major things is that they had a lot of customer sets to compare all these attacks to. Since they had a trusted reputation, they probably were hired by a lot of these places that were getting pinpointed in those 5-year plans of China's APT, or China's 5-year plan where they wanted to aggressively go after specific markets. So they probably had a lot of the aerospace, government customers as well that they had access to all those machines to possibly get that information. Other than that, does that answer the question, I guess? Okay. Yeah, no, yeah, I mean, yeah. Mhm. Yeah, that's true. Um, yeah. Well, I'm assuming some of it probably is a sell product maybe, but a lot of it, I mean, I don't think anyone's going to deny that we're not getting attacked from certain entities outside because, yeah. What's that? Yeah, he does, doesn't he? Yeah. Well, be like good guy Greg. Oh no, you're fine. Yeah, I like those questions. I found this question this picture on the internet this morning as well. And sloths are awesome, right? This guy is freaking magnificent. So, this is where I can be found. Again, my name is Nathan Monnier. Contact me here at these different email addresses or on Twitter at HackHunger or Facebook /HackHunger as well. Or look me up on my name as well and add me as a friend. Love discussion, so love HackCon, love cons. So let me know how I did. And speaking of Casey, if I can ask some pointed questions, if someone would come up to me and tell me how I can improve on this talk, I would greatly appreciate it. So always looking to improve, always looking to see maybe I missed something that was blatantly apparent and I just didn't cover it, but you happen to think of it. So other than that, thank you.